Okay, so starting on the warm-up page, lesson number 1, they're asking you to not only name the sheet, but its most specific name. A couple things I need to add to this before we can get specific. I do need to tell you that this is 90 degrees. Remember?
It's a right triangle.
That is a right triangle. Don't write too big. There's not a whole lot of line space for some things. Second shape. Don't always assume that certain sides are equal. I'll tell you. The only thing I'm going to tell you with this shape right here is that this is parallel to this, and those sides are also equal in length. I'll tell you that as well. This is parallel and equal in length to that. What's it called, Nick? That is your parallelogram. Now, I have a bonus question on this for you. How come it's not a rectangle? Angelina. You got it. Because, see, you're going to learn this a little bit later on here on this page. This shape right here, which I'm not going to tell you the name of, but you probably already know what it is also a parallelogram. But it's a very unique parallelogram called a
rectangle,
which we'll get to. Angelina, get it. Okay, top drawer, you're good. Okay, so that's a parallelogram. This triangle, do not assume anything unless I tell you something. And all I'm going to tell you about this third shape is that these angles are all less than 90 degrees. It's the only thing I'm going to tell you. Wait. Let me say acute triangle. Let me say isosceles triangle. Let me say an equilateral triangle. Remember, don't assume anything. If it's isosceles, I'd have to tell you that this side and this side are equal. But I'm not telling you that. If it was equilateral, I'd have to tell you that all three sides are equal. But I'm not telling you that. The only thing I am telling you is that the internal angles are less than 90 degrees. So therefore, we can only call it an acute triangle. This we already said is the rectangle. In order for this to be a rectangle, though, I would have to confirm with you that these are indeed 90 degree angles. I have to tell you that. Or show you that with little tiny bumps. This shape, this last shape, the only thing I'm going to tell you is that these sides are parallel, and that's it. Don't assume that they are equal. Obviously, they're not. Don't assume anything on angles. You know what's it called? It's a trapezoid. All right, well, let me ask you, what is the definition of trapezoid? What makes a trapezoid a trapezoid? No?
Yeah, I think it's what only has one parallel.
Right, only one set is parallel, which is the size I put in green. Parallelogram has to have two sets. Opposite sides are parallel. Okay, quadrilateral. Quadrilateral is the most broadest of categories. Okay, by definition, quadrilateral has to have two things. You know what those two things are?
I know both. I know.
Blue, what's one of them? Has to have four sides. Has to have one more other thing. It's the most obvious, basic thing, but you have to include it in your definition. Nope. At the very least, it has to have four sides. And what else?
They have to be parallel.
Yeah? It has to be an enclosed shape. So if I do 1, 2, 3, therefore that is not quadrilateral.
That's a W.
It has to be closed off, okay? Very basic, but we don't think about that, but that's true. So now, it is the most broadest of categories. Many shapes will fit into the quadrilateral category. But of the 6 we did, which ones are quadrilaterals? Chris, go.
Rectangle, the trapezoid, parallel.
You got it.
Oh, wait.
Watch, I allow you to do this name. You can abbreviate this. Rectangle, trap, p-gram, I do. Little p-gram is fine.
P-gram. My grandmother.
It's like P. Diddy. She's just 2 little rap music on the
It's
side.
like, yo,
She's p-gram.
dust. Word! That's why
That was funny. I put a star next to parallelogram because they're not a trick question.
there's none.
Don't call out. Don't call out. What shape or shapes are parallelograms? 10. He is right. There's 2 of them. Because all rectangles are parallelograms, but not all parallelograms are rectangles.
That's so good. There's such these are any other shapes like rectangle.
Quadrilateral is most broad. What's the most specific or least broad? And I'll give you an example. The shape I'm thinking of satisfies all of the following criteria. They're quadrilateral. You tell me, you gotta raise your hand. What shape am I thinking of? Quadrilateral. It's also parallelogram. It's also a rectangle. And it also has, not in your way, something else that makes it the shape that I'm thinking of.
Closed.
Yeah. I'm going to say square.
Put the ball.
Square fits all of the characteristics of quadrilateral, parallelogram, rectangle. I'm going to ask you to take a step further than that, okay? But what makes the square unique? It has all of those things, plus what else?
4 sides.
So does a rectangle, though. It needs something else besides those 4 internal 90 angles.
It's smaller than a rectangle.
Oh, yes, you do.
It belongs to
A square. What's the difference between a rectangle and a square? You can do it.
all sides are.
That's it. All sides have the same measurements. That's that top drawer. Okay?
Is it simple to a ball?
Okay. Is there a bottom to this? I forgot. There is. Okay. The focus of this lesson is determining the area of parallelograms. In order to do the area of the parallelogram, backtrack for a minute. Now tell me, what was the area for the rectangle? Come on, you should know that. You just did it. You just did it on your last quiz. I'll get you started. A equals what? Hold on now, George. Length times width. Tell me if you've seen it this way in 5th grade, because we're going to go and refer back to this particular formula. Length times width can also be called base times height. Did you learn it?
No.
You can get away with length and width in rectangles. Because really the length is the base, and the width is the height. The sides are perpendicular to each other. You can't call it length and width in a parallelogram because, as you'll see, the sides are not perpendicular to each other. You'll see what I mean, but it's still essentially the same. Only the place where it gets a little confusing is determining the height. That's kind of going to be the gist of this lesson. You've got to be able to figure out what's what in a parallelogram. All right, and we're going to get to it. But before we get to that, I had one person in period 2 that was able to see this. Some of you guys that are really good visual learners, it's spatial relations. In this particular parallelogram, do you see the rectangle?
Yeah.
And where do you see it? Good. What about on the side? Sort of, kind of.
It's like a stretched out.
Dylan, what do you say? Okay. What if I gave you this? Let me go to Kaluch and I'm going to ask you a follow-up question that might click with you.
I can click it. One side stretched. It's like a 3D.
If I gave you a parallelogram of this size and shape, and I gave you a pair of scissors to make a rectangle,
Yes.
what would you need to do? Shape. Okay, and then do what? Cut along the dotted line and then do what? That's your first step. Okay, I can cut it here, but then what? Now I have 2 pieces left over. I want you to try to make a rectangle with the pieces I'm giving you. How's that?
Oh.
Tangram, they call this. You see it.
The 2 sides you put on top of each other.
Oh, sort of.
Oh.
Wait.
If you cut off the side that's essentially on the other side.
You mean cut along here, and then do what with this?
Take it on the other side.
Like that. Okay? That's why the 2 formulas, see, this is called the base. What's the base? What's the measurement base? From here to here, it's 14. What's the height? In fact, let's do this as we do it. The base is 14. Write this down for a minute. What's the height? And be careful here. And I'll give you a hint. Height is directly up and down. That's your hint. Jake, what's the height? Do you agree? 6.
Yeah.
How many think 8? This is called a throwaway number. It's trash. They put it in there because sometimes they'll ask you perimeter and you would need it. But this is my height, 6. And my base is 14. That's why the 2 formulas will work. We're ready? 14 times 6, base times height, right? See it? Ready, watch. Length, 14. Width, 6. It's the same 2 numbers. That's why the 2 formulas, base times height and length and width, work. I haven't changed the amount of space that this shape takes up in any way. All I did was rearrange it. Oh, it's still quite loud. Well, it's dotted line there just for illustrative purposes. So the whole gist of this lesson is now that we know it's base times height, you got how much time you got? 8 minutes. 2 minutes? All right. Well, we're going to be perfect. So your homework is very manageable tonight, but let me get you through the exercises. We have to determine which numbers we need and which one are what we call trash numbers, numbers that we don't need. So scroll to the bottom. I put this bold-faced shape in here for a reason, because that's the shape that we have to find the area of. However, there's a bunch of numbers here we don't need. First, tricky question. What's the base of that parallelogram? And again, focus on the solid, bold-faced lines. Matt, what do you say? How many say 12? A lot of hands up. This is something else. Hey, what do you say? Let me say 17. think always base and bottom start with the same letter. Base and bottom, so that's your hint. Chris. I see what you're trying to do. Don't add it. Think even simpler than that. Because by definition, opposite sides of a parallelogram are parallel and equal. Tell it. Does everybody see why it's 9? This is 9. So this is 9. That's my base, guys. 9 centimeters. Hopefully that's the harder one for you to get. What's the height? Stephen. Always think up and down is our height. Even sometimes you see the height outside of the parallelogram. Up and down is my height. Therefore, what numbers do we not need? Matt. 12 and 17 are called the trash numbers. Now we've got it. Now it's just basis times height in the formula. And you're able to do it. Let's just do one of these exercises with bell rings. How about this guy? Let's do the trash number first. Which one do you not need? Jake. Say it again? Right. 5 centimeters. If it helps you, the side that's at the angle for area is always our trash measurement. We don't need it. And luckily, we only have 2 left, and we do need those. You write the formula. Jake, what's the base? Good. Don't worry about units until the very end. Stephen, what's the height?
The height is 5.
That's our trash number. We don't need it. Up and down. 4. Remember, this line is dotted just to show you what the height is. Multiply the 2 numbers. What do you get? And finally, what are the correct units for area? Squared centimeters. Sam's little 2. All right, so your homework is to finish through page 5. You have, what page is this? 4? 4 and 5 are all you. Okay? We'll go over it first thing tomorrow. We have short periods all week.
No, not Friday.
Not Friday.